Hi, everyone. Welcome to the latest in the Mining Industry Human Resources Council's Mining Needs You Career Ambassador webinar series. Mining Needs You is a national career awareness campaign supported by a coalition of industry partners that's designed to inspire the next generation of mining workers. The Career Ambassador program raises awareness among elementary and high school students by having our ambassadors deliver presentations in class and virtually about the industry and their career journeys. More information is available at the miningneedsyou.ca website and at the mir.ca website. That's MIHR.ca. I'm William Meyer. I'm the Director of Communications and Career Development at MIR, and I'm happy to welcome today's Career Ambassador, Leila Abbasian, who will deliver a presentation titled Sustainable by Design, Modern Engineering for the Mines of the Future. I'm thrilled to have her join us in celebration of the World Engineering Day for Sustainable Development, which took place on March 4th. And before I introduce Leila, I'd like to acknowledge that I'm coming to you today from MIR's office in Ottawa, which is situated on traditional unceded territory of the Algonquin and Anishinaabe people. We recognize the stewardship of this land. We also acknowledge the contributions of all First Nations, Inuit, and Métis people in shaping and strengthening our communities. We also recognize that you are joining us today from many places and acknowledge traditional owners and caretakers of those lands. So some quick housekeeping notes. This webinar is being recorded and it's going to be uploaded to the Mining Needs You YouTube channel. Attendees will receive an email with a link to the video and a webinar survey that we ask that you take a couple minutes out to complete. And we set aside 10 to 15 minutes for a Q&A session right after Leila's presentation. So please type your questions during the presentation in the MS Teams chat feature. So now it's my pleasure to introduce you to Leila. Today, she'll share what's sparked her interest in engineering and sustainable development. Leila is a process engineer and a PhD researcher at Memorial University of Newfoundland. She sits at the intersection of sustainable minerals exploration and applied engineering. With more than 8 years of experience across mining, energy infrastructure, and industrial operations, she brings a rare blend of operational leadership and research-driven problem solving to the future of mineral development. Her doctoral research focuses on advancing high-frequency electromagnetic technologies to improve mineral exploration accuracy. She has enhanced subsurface detection, precision. She's helped reduce uncertainty, optimize drilling decisions, and support more responsible resource development. Leila also serves as president of the CIM METSOC student chapter at Memorial University. So under her leadership, the chapter was recognized with the National METSOC Outstanding Student Chapter Award for 2 consecutive years. Leila is deeply committed to engineering that is sustainable by design. She's passionate to help shape a mining sector that is innovative, environmentally responsible, and resilient for the future. So Leila, I thank you for joining us, and the floor is yours for your presentation.
Yeah, hi everyone. Thank you so much, Will, for the introduction, and thank you to Mining Industry Human Resources Council for inviting me for today's talk. My talk today is about sustainable by design, modern engineering for the mines of the future. I hope that you enjoyed the talk, but before going through the talk, I would like to also give a land acknowledgement to the lands that Memorial University is located. We acknowledge that the land on which Memorial University campuses are situated are in the traditional territories of diverse indigenous groups, and we acknowledge, we respect the diverse histories and cultures of Beothuk, Mi'kmaq, Innu, and Inuit of the province. So, as I was introduced to you, my name is Leila Abbasian. I'm a PhD candidate in process engineering here at Memorial University. My background is in process engineering and geophysical exploration, and I'm passionate about developing sustainable technologies for the mining sector. In addition to my academic work, I'm actively involved in volunteer leadership and community engagement, and I'm also interested in entrepreneurship and innovation in resource industry. Today, I'm happy to share my journey and experience with you. So starting back from my life in Iran. This slide summarizes my early academic and professional journey in Iran from 2008 to 2021. I first chose engineering because of my strong interest in math and physics, and I was admitted to a high-rank university back in Iran. I completed my bachelor's degree in technical inspection engineering at Petroleum University, where I also gained practical experience through multiple internships in big refineries in Iran. I then continued my master's degree in the same field, focused on operation safety, human factors, and life assessment of equipments that are operating at high temperatures and pressure, while also working as a teaching assistant and a lab assistant. After my graduation, I entered natural gas industry, first working as a process engineer and later advancing to a director of operation role, where I observed activities for 20 technicians for operations of gas regulating stations and bringing the gas safely to power plants, commercial and residential customers. These experiences over 6 years built my strong foundation in engineering practices, safety, and industrial leaderships. At a point in my life, I've decided to immigrate. It was an important turning point in my life. And it was a transition from Iran to Canada. After completing my IELTS exam and successfully receiving admission from Memorial University, I decided to pursue academic and professional goals internationally. Moving to Canada wasn't only a geographic change, but for me, it was also a major personal and professional step, opening new opportunities to research, innovation, and global collaboration in mining and engineering sector. Looking to my life in Canada from 2021 until today, I am currently pursuing a PhD at Memorial University, where my research focuses on developing sustainable geophysical exploration techniques, particularly using borehole ground penetrating radar for volcanic massive sulfide deposit exploration. I'm also a core characterization lab assistant. I'm gaining hand-on experience with rock property measurement and characterization. Along my research, I have activities in volunteer leadership. I serve as the president of CIM MedPsych student chapter at Memorial University, and I have contributed to organizing the Mineral Resources Review Conference, which is a big conference held annually here in St. John's. I was honored that our chapter received the MedPsych Outstanding Student Chapter Award. I also volunteer as a Meher Career Ambassador, where I'm giving a talk today, and I serve as the board member in the Iranian Moms NL. In parallel to this, I have been developing my entrepreneurial skills through several innovation and startup training programs here in St. John's entrepreneurial ecosystem. This complements my technical background and supports my goal of creating impactful solution in the mining and exploration sector. My research is around development of electromagnetic wave velocity estimation techniques and imaging fluid for enhanced borehole GPR surveys in mining exploration, in mineral exploration. So I'm starting with a story about a deposit called the Romeo and Juliet deposit. Here in this picture, you can see a narrow vein deposit located in the Romeo and Juliet deposit near Anaconda Mining Point Roseau site in Newfoundland, Labrador. The deposit contains high-grade gold, but it's extremely difficult to mine this kind of deposits due to its steep angle and very narrow vein geometry. This makes conventional methods uneconomic, despite of estimated value of up to $100 million. So to overcome these challenges, Memorial University Drilling Research Program, which I am a part of that program, launched a research and development initiative to design and optimize an innovative mining technology specifically suited for steeply dipping narrow vein deposits. It aimed to unlock previously inaccessible mineral resources due to depleting the current mineral resources that could be extracted using the conventional methods. So looking at all of the critical minerals, as you can see, Romeo and Juliet narrow vein gold deposit is only an example of many kind of VMS-related economic minerals, including iron oxides, sulfides like pyrite, pyrrhotite, base metals, minerals like chalcopyrite, galena, sphalerite. These are all could happen in the form of steeply dipping narrow or isolated single vein geometries. In such a setting, although the mineralization may be very high grade or geophysically detectable due to their strong conductive and magnetic properties, the limited thickness, steep orientation, and discontinuous nature of the vein often make them uneconomic to extract with the conventional mining methods. So understanding this mineralogical composition and their geometrics is a step towards more innovative extraction methods. This slide shows different geophysical methods used for detecting critical minerals. So similar to Romeo and Juliet, you can see that the mineralized zone may occur in a steep, narrow, discontinuous veins. But in the geophysical techniques, if we want to take a look at them, not a single geophysical technique can detect all the relevant physical properties. Exploration programs are integrating multiple methods. For example, electromagnetic, IP, magnetic, gravity, seismic, ground penetrating radar. All of these techniques are integrated to more accurately explore and detect these mineralization zones. For example, gravity is for density, magnetic surveys are for susceptibility, and electric methods are for conductivity. These are integrated geophysical approaches that are essential for accurately detecting, characterizing, and imaging narrow vein VMS mineralizations and these methods support the innovative mining solutions. So looking to this slide, steeply dipping narrow vein deposits such as the VMS ones and an example in the Romeo and Juliet needs advanced detection and extraction approach because conventional mining, as you can see, for example, underground mining or open pit mining, they are not economic for this kind of deposits. But here, the new technology, which is called surgical mining, this is a proprietary technology, and in conjunction with Memorial University, it is designed and developed. It offers a targeted solution that is faster, cleaner, and less invasive. This is Novamera proprietary downhole sensor that can collect more accurate subsurface data than traditional delineation methods. This is a high-resolution data that supports AI-driven digital twin models of ore bodies, enabling the decision of precise drilling trajectories. This company's proprietary extraction system can be deployed on conventional large diameter drills that help reduce cost of drilling. So the proof of concept for this design demonstrates how the full system is applying. First of all, as you can see in the middle picture, I highlighted the middle picture because this is the main subject of my research and my contribution to the program, to the whole program. An NQ size diamond core hole is drilled and the guidance tool, which is a imaging tool, is deployed on wireline to image the ore body in high resolution. Then a large diameter drill equipped with positioning control and course correction technology follows the AI-defined trajectory to selectively extract the mineralization, with cuttings removed using reverse circulation. Finally, the hole are backfilled to maintain ground stability. You can see how the land use is decreased here in this method compared to the conventional methods. So here you can see a comparison of the infill drilling imaging techniques with the current Novamera drilling technique. You can see how surgical mining can unlock access to narrow vein deposits very more efficiently. And with a value of $6 trillion worldwide, it can unlock the access to the narrow vein deposits like the Roma Angulate, and it collects 49 times more data compared to traditional methods. It can generate up to 95% less waste and water usage and 44% reduction in the greenhouse gases emissions, and drastically lower water usage and surface disruption relative to the conventional mining. So since mining companies face a lot of pressure these days and a lot of shrinking margins, the appeal is clear here. We cannot transition to a clean energy without mining, of course, but the mission here is to provide the tools that the industry needs to mine the resources that are critical to a net zero future, and to do it faster, cleaner, and more cost effective. Now I'm going through my contribution to the whole program. Until now, I was giving a general overview of the technique in sustainable mining by surgical drilling. My contribution to this research is to enhance the EM characterization for geophysical surveying that plays a critical role in this method, particularly in the borehole environment and with the VMS deposits. I'm integrating experimental measurements, simulation, and drilling fluid development to answer two main problems. The first one is the imaging fluid resolution, as we aim to eliminate the effect of groundwater on the signals for the purpose of imaging, and to EM characterization for the purpose of accurate data inversion. Here you can see a brief background or a literature review of the method. As you can see, electromagnetic wave velocity is one of the important parameters for targeting minerals in the scale of centimeter. It is mainly controlled by a property of minerals which is called dielectric permittivity. Dielectric permittivity is really important, so we need accurate techniques to measure that. This slide summarized on the right side laboratory methods that are being used for permittivity measurements, from coaxial probe, transition line, and other methods, and also in situ approaches for EM wave velocity measurement that you can see according to the formula is closely related to relative dielectric permittivity. So here is a big picture of the significance of my study and the key research questions that I'm trying to address. Today, I'm only talking briefly about the highlighted ones, but here emphasize the importance of improving electromagnetic characterization and borehole GPR imaging for complex environments, for example, this VMS and narrow vein deposits. My study develops reliable laboratory methods for EM properties characterizations and enable more accurate and cost-effective subsurface characterization. Also, my study contributes to development of imaging fluids, which enhance the imaging resolution. So here are the big picture of all the research gaps that exist, and I try to address the overall research gaps. The overall work integrates the laboratory measurements, simulation, optimized imaging fluid to enhance high-resolution borehole imaging, and it supports accurate delineation, which is necessary for sustainable mineral exploration and development. Going through the fundamentals of the method I'm working to, here the slide presents practical methodology for measuring electromagnetic wave velocity using the high-frequency EM methods. This is important because EM signals needs the EM wave velocity to accurately convert travel time of the signals to the location of the deposits. These methods rely on measuring the two-way travel times of reflections from a metal plate that is under the sample, which is a NQ size core samples. A hyperbola will be created by moving the sensors on top of the samples, and from these signatures we can calculate the two-way travel time, and using the sample dimensions we can calculate the EM wave velocity and also dielectric permittivity. There are so many steps for accurately doing this method that I'm going to talk about in this slide. So everything starts with simulation to make sure that the method is actually practical. We start with simulation. The simulation workflow use optimize antenna frequency and validate the experimental setup. So first of all, the aim of simulation is to understand the geometry of experiments, the frequency that we need to resolve the boundaries of these samples, and also the all of these parameters that helps us actually solve Maxwell equations to understand the EM wave propagation under these conditions. If reflections are not clearly distinguishable, we adjust the parameter to accurately estimate the two-way travel time inside these samples. After simulation, so the main aim for the simulation is designing the experiment part. After the simulation, we do the experimental configuration. As you can see, there are two experimental configurations here, which we examined using the simulation, and then we reach out an optimized configuration for our experiments. Here you can see different sizes of NQ size cores and a signal processing workflow, all of which helps us to validate if the method is working for different kind of rocks and minerals. So we use different kind of samples with different lithologies, and we change our configuration and experimental setup to reach out the best results. Here are the simulation results. As you can see, we examined different frequencies, and the simulation itself helped us to understand wave propagation paths. As you can see clearly, the signals are passing through the sample, hitting the bottom of the sample and reflecting back and being received by the receiver. Our experiments tested 3 different frequencies, among which we validated 2.3 and 2.7 gigahertz frequencies as the best frequencies to resolve the boundaries. Because of the differences in the wavelengths of these signals, the ones who has a sharper wavelength could observe the both sides of the boundaries that are important for calculating two-way travel time. Here you can see an animation with the first configuration. As you can see, the main problem with this configuration was the reflections from edges of the glass and the concrete support legs. And because the signals, when they hit the edges of the glass and concrete, they come back to the receiver at the same time that we expected the main signal from bottom of the sample arrive at the receiver, and it makes us hard. It makes it hard to detect which signal is coming from where, and it needs a lot of signal processing stages to clear that artifacts. But we refined the simulation setup, and we've used a wooden rail system. So here you can see there is nothing but the air gap under the antenna, and this helps us to actually eliminate that artifacts and noises that were coming from the edges of the glass and the support legs, and it helps us clearly see the edges of the samples. As you can see here, for the both of the configuration, the left side and the right side, you can see in bottom the actual experimental results. The first one needs a lot of signal processing stages to actually eliminate that artifacts. But moving to the refined experimental setup, the signal processing were more simple, more robust, and actually we could automate that signal processing stages to process hundreds of results in minutes. So this refined experimental setup was very, very more robust compared to the previous one. This slide shows the results for 4 different lithologies, gabbro, sandstone, limestone, and granite, which shows effectively how we could calculate EM wave velocities in different lenses of these samples, and all the lenses gave us the same velocity measurements, and the calculated relative dielectric permittivity lies perfectly under the literature values confirmed by many other scholars. So we could validate that the method works for homogeneous samples that we've selected. Currently, we are developing the method more under anisotropic and inhomogeneous samples that we could secure using the St. John's core storage library by the help of the Mineral Resources Department here in St. John's. I would like to give my acknowledgements to my co-authors and supervisors, Dr. Alison Leach, professor at Earth Sciences Department, Dr. Stephen Butt, professor at Engineering Department, and Dr. Abdusalam, the project manager of the surgical mining technology. And I would like to connect with all of you. So if you would like, you can scan the QR code here to connect with me more on LinkedIn. Thank you so much for your attention.
And thank you very much, Leila, for that presentation. Now we're getting into the Q&A portion of the webinar, and I do have a few questions that have come in, so I'll just ask you a question, and then you can give your answer, and we have a few minutes for that. So the first one I have is that, as you are somebody who's involved with MetSoc, what advice would you give students who want to network in the mining sector but aren't sure where to start?
Yeah, so if I want to talk about my own experience, it was back in 2022 when I joined MetSoc chapter. So here at Memorial University, CIM and MetSoc chapter, I joined together. Students at the Process Engineering Department started to make the chapter activated back in 2021, and I joined the chapter at 2022, and I became the president at 2023. I can tell joining a student chapter, or even if there is no student chapter in your department, look to see which institution and which organizations are willing to create a student chapter in universities. Many of them allocate funding for students to create a chapter and have student activities to connect the students with industries. From my experience, we've tried to have different events to connect students with industry persons in different events. For example, from industry talks, CIM offer distinguished lecture series, for example, where we can invite professionals to the university with the funds that CIM give to actually get students exposed to things that are going out in the industry. There are so many programs CIM is offering, for example, the mentorship program. So when you are going inside a student chapter only, you can realize what opportunities are out there to get connected to different professionals and different industry. The other main thing is always be active and go to the conferences as much as you can. For example, even this student chapter that we have during the past 2 years funded 50 students to waive the registration fee for attending Mineral Resources Conference as a volunteer. And they had the opportunity to get connected to many companies, many professionals. I can tell being active in a student chapter is a very good opportunity to get connected to the industry and professionals.
That's great. Thank you very much for that. And kind of in that vein, how do you see schools being able to support young people pursuing careers in mining and specifically sustainability?
Yeah, for sure. From my experience here at Memorial University, the most important thing that schools can do is to be really active in their career development office. For example, here there is a career development office which holds different programs, from professional skill development programs where they try to educate the students in terms of how they write their resumes, how they write cover letters, how they do their interviews. They leverage their skills through these trainings, and also they provide, at the same time, they provide opportunities for them to do internship positions, for example, or part-time positions. And also they provide different co-op positions for undergraduate students, for example. So I think the main thing schools can do is to make the career development offices and enhance relation with industries, because I know many industries benefit even from hiring students from different universities in Canada, benefits in terms of like tax waivers or other things. So many industries are actually willing to come and have contracts, research contracts with universities. But all of this goes through the career development offices in universities. So ask your universities where these offices are located and go see what kind of opportunities you can find there.
Perfect. Yeah, thanks for that. Now, another question I have, so more focusing back on your presentation and its content. Would you be able to talk more about the sustainability aspect of your work, and how do you see sustainable development evolving specifically in mining?
Yeah, so from the general perspective of people, when asking them, what do you think about mining? They think that mining is an environment killer. So from the previous background of the mining, which is the open land mining or other methods of conventional mining. But with today's technology, as you can see, so the big mineral sites are depleted. And the reason these technologies are being evolved is that it's not anymore economic to use conventional methods on the one side. And on the other side, there is no need to, for example, have that uh, kind of permissions for big, for example, land permissions to do that underground minings. So as you saw from our research project, this surgical mining techniques doesn't need a lot of land permissions. With a little land permission, they can do that. The other things that people need to look on sustainable mining development is what current industry is doing in terms of water usage and emissions. So as long as the new technologies could reduce water usage in mining industry, could reduce emissions, carbon emissions, and they could more accurately extract these minerals, I think this is the way that we are going forward a more sustainable mining industry. And actually, with the government, we are really grateful that Canada government is paying a lot of attention to designing new technologies for sustainable exploration and sustainable extraction of critical minerals. There are so many funding available for new research, for startup companies even, to develop new sensors, develop new technologies to more sustainably extract that minerals.
Great, thank you. There's two more questions left, and the next one actually falls specifically into what you were just saying. The one question here is, what skills should I start working on building right now to be ready for those technologies and tools that are coming to shape modern mineral exploration?
Yeah, so a really hard question to answer. You know, it's really hard to and challenging to keep pace with the rapidly evolving technologies right now. But what I can tell from my experience, being a continuous learner is the main thing, because we shouldn't think that I'm at university to get a degree and then get hired. No, even if you're starting your professional career, being always a learner try to learn new technologies, evolving technologies, try to read, for example, trending magazines in the mining industry even. It's like a hobby for me to read CIM magazines because all of these trending technologies, they are, first of all, published there. And if you keep pace with getting yourself familiar with all of these news and try to learn what you really like to learn, not all of the things. So try to know your passion, go through what you like, and start learning them. Be a continuous learner. This is what really helped me. I tried, for example, in my entrepreneurial journey. It's around 2 years now that I'm trying to participate in any kind of entrepreneurial skill training programs. I know that it might take like 10 years or more to maybe have a good idea to turn it to a business, or for example, to turn research here, being an academic translator that translates research to market. All of these needs people to be continuously learning different skills, not only focus on get hired somewhere and think that things are done when you are hired. I recommend being a continuous learner. Yeah.
Well, that's really good advice. And the final question we have actually is about advice. What advice would you give to someone looking to transition from a different industry into exploration and mining?
Yeah, good question for me, because I already worked in the natural gas industry for 6 years. My background, my education wasn't in mining at all before I come to Canada, and I tried to transition to the mining industry. What really helped me was to focus on my transferable skills. So there are some skills that are common in different industries. For example, your communication skills, your critical thinking skills, to know what kind of solution you need to seek for the problems that you need to solve, which is called the critical thinking skill. I think more focusing on the transferable skills helped me to transition and to introduce myself to the professionals here for when I wanted to get an admission from a research in the mining sector, from a research program in the mining sector. I didn't have much background on the geophysical knowledge, but I had knowledge of non-destructive testing because I was a technical inspection engineer and I knew the fundamentals. So I applied that fundamentals that I knew from my math and physics courses, even back in high school. Many of us read that fundamentals, the ones that are reading physics and math. And these kind of fundamentals are common in many industries that you can apply them in different industries. So I think more paying attention to the fundamental skills you have, to the transferable skills like communication skills, and try to enhance them. You can easily transit from one industry to the other.
Great. Well, thank you for sharing your knowledge and experience and your advice and taking the time to participate in this webinar with us today, Leila. I really appreciate it. And I encourage everybody here to follow Mir and Mining Needs You on social, and to visit mirandminingneedsyou.ca for more information. So with that concludes our webinar, and I hope that we will see you all again in a couple of months for our next Mining Needs You Career Ambassador webinar. So Leila, thanks again, and we'll see you all later.
Thank you so much. Thank you for inviting me today, and I hope you have a great day.
You too. It was great. Thank you.